We've got two learning outcomes for this lesson, and it follows on from the lesson on microscopes, or the electron microscope. So we're going to recall what is meant by an instrument's resolution. We're going to explain why some cell structures can be seen with an electron microscope but not with a light microscope. So we've already used the term magnification, so we've got a good idea of what that's all about, but resolution means something else. So if you look at these two letter N's, they've been magnified, they've been increased in size by the same amount. So the magnification is the same, but we can clearly see that the resolution is different. In other words, the N on the left has been resolved more, and it appears far more clear. We can see it in greater detail. We're all familiar with using digital cameras. So here we've got a car number plate. As we can see, that's very, very far away. So the camera zooms in or magnifies on that number plate. And these are the images created. Now, as we move in an anti-clockwise direction, the images are becoming much, much clearer. We can see them in more detail. So this one here, this image here, is the image with the higher resolution. We can make out the letters and the numbers far more clearly on this image. In this example, we're looking at video cameras. So this is CCTV in a shop to perhaps prevent shoplifting. So it's not enough just to be able to zoom in on people, you know, these supposed shoplifters. Magnification is not enough. You can have excellent magnification, but without the resolution to see somebody's face and identify them. So it's the resolution that allows you to see in detail. Yep, magnification is important, but resolution is just as important. So let's have a look at a definition for resolution. It says here, the detail obtained by a microscope also depends on its resolution, so not just its magnification. So what is resolution? This is defined as the smallest distance between 2 points that can still be seen as 2 points. So for example, here we can see one big thick line. So this is what we might be able to see under a light microscope. If we then use an electron microscope, for example, we'd actually be able to see two thinner lines. In other words, we've resolved that thick line into two thinner lines. That's what's actually there, and we've been able to resolve that. If we zoom in onto those two thinner lines then, so there's the two thin lines. The resolution is the distance that we can still see between these 2 points. There's the 2 points. So this has a particularly high resolving power. So this is what I can see with my electron microscope at high resolution. If I drop down the resolution now and I'm using a light microscope, instead of seeing the two separate lines and those two separate points, I'm now back just to seeing one single line. I can't resolve this line to see the two separate points. So the high resolution of an electron microscope is what explains the fact that we can see things much more clearly. Inside a cell, we could have these tiny little structures called ribosomes. So these are perhaps the smallest subcellular structures inside a cell. Impossible to see them in a light microscope, but we can see them in an electron microscope. In a light microscope, we can barely see the mitochondria. That's a mitochondria. We can barely see that in the light microscope. In actual fact, it's even smaller than that. This is not done to scale. But in the light microscope, can't see it, haven't got the resolution power, but using an electron microscope, we can see the likes of mitochondria and ribosomes in particular. Okay, so I've explained what resolution is, and I've told you that an electron microscope with a higher resolving power allows us to see things in much more detail. We can see the ribosomes and we can see the mitochondria.